Hello everyone, welcome back to ptet.chemistry channel. So in this video, this is a continuation of section 1, at least in my categorization, that is on mole calculations and stoichiometry. So this will be a 5-question part series on this topical MCQ. Without further ado, so this question is asking you on the volume of nitrogen that this reaction will produce at room temperature. So we are under room temperature and conditions, so we can think about the molar volume of gas being 24 dm³ per mole, and that's because they were giving us the option to work in dm³. But of course, you know that if they give you the option in cm³, we could have also opt to use this 24,000 cm³ per mole for our calculation instead. Okay, people who are used to my method, you will have realized that I like to use mole fractions. So this is what we want to find, and we have 50 grams sodium azide, and that's what we have. So I'll set up my mole fractions like that. From the balance equation, 2 mole of sodium azide give me 3 mole of nitrogen. So it doesn't matter which way around you put it, but since I put the mole of nitrogen on top, on the right hand side I will follow through. 3 mole of nitrogen gas is produced from 2 mole of sodium azide. So I simply follow through by knowing the idea of equal. You know, you learn what is the meaning of equal. What is on top is equal to what is on top. What is at bottom is equal to whatever is at the bottom. This is from the stoichiometric equation, the balance equation. What actually happened in reality, that is what I'm going to put here. How much volume of nitrogen you actually get, and how much mole of sodium azide you actually reacted. Okay, so the sodium azide that actually reacted is given as a solid there, therefore it's 50 grams of sodium azide. So the MR of sodium azide, if you go into the data booklet in your periodic table, you have 23.1 plus 14.0 times 3, I get 65.1. So because I'm given the mass in gram, so the mass over the MR is going to be the mole of sodium azide, alright? And because the top bit is a nitrogen gas, so I'm dealing with volume of nitrogen, and I'm going to use the one which is 24 dm³ per mole instead of this, because the answer has been expressed specifically in dm³. So I'll put it 24. By using 24 here, it means that the volume of nitrogen here has to be in dm³. When you have dm³ divided by dm³ per mole, you're going to get mole of nitrogen. So my units balance out, and it's still the actual mole of nitrogen produced, the actual mole of sodium azide reacted. Next bit is just about rearranging your equation. So I'm going to move that here. I'll probably try to do it in not all in one step, so that you can see what is going on. So I move this up there. I maintain that. I could have written it on the right hand side, but I don't want to. I hope you can see that. But all this while you keep maintaining the equal, yeah? Okay, so what is on the what is the definition of equal? Okay, you need to be well aware of that. So I'm just bringing down everything, and I'm bringing my 24 up there to become 24 over 1 times this whole thing. And I got 27.649. Looks like they might have used 65 instead of 65.1, but this is the closest to my 27.6. I can't run it out to 27.7 because this is still lesser than 5, but this is going to be in dm³, and the closest answer I can think about has to be 27.7 there. All right. Next question. This is on question on it's on acidity. So they are saying that which substance in 1 mole per dm³ aqueous solution, same hydrogen ion concentration as 1 mole per dm³ of hydrochloric acid. When you have hydrochloric acid, it's a strong acid. You learn more on the quantitative part in A2 chemistry under ionic equilibrium. But in AS, you know it's a strong acid. It dissociates fully, right? Okay. So if you have 1 mole per dm³ then your concentration there is going to be 1 mole per dm³. There's no change in volume because all of these come from all of that. So if you have the total volume here being V, the total volume here is going to be V, and the total volume here is going to be V. So 1 mole of this give you 1 mole of this. 1 mole per dm³ of this give you 1 mole per dm³ of it, alright? So what do we have here? What I can cross out is, I can cross out ethanoic acid because this is a weak acid. What do I mean by weak acid? The weak acid dissociate partially. So I use the reversible sign. They dissociate partially in water to give you the H plus ion. So it's not like 1 mole of this will give you 1 mole of it. No, because most of this, the equilibrium lies on the left hand side. That's why it's very weak acid, right? Okay, so that's why we do not associate it being 1 mole of this will give you 1 mole of that, because that would mean it's a strong acid, whereas here you have equilibrium. So I can cross out the weak acid. I can cross out C because there is going to be the base where my concentration of hydroxide is so much greater than the concentration of acid. You know, in water, when you talk about water, water has a pH of 7. You call that neutral because the concentration of H plus equal to the concentration of OH minus. The tip of the balance when you go into the acidic regime is when you have more H plus than OH minus. Your concentration of H plus is greater than the concentration of OH minus. That's why you become acidic. When you become basic, it's because you have more OH minus than H plus. So they have the same hydrogen concentration as an acid. I can cross that out. Between HNO3, so that is HNO3, and this is H2SO4, which one should you go for? The HNO3 can dissociate to give you that. This is what we call a monoprotic acid. They call it monoprotic, but there's another name for it. It's called monobasic acid. It's very strange, right? They call it monobasic, but it's an acid. I know, but that's just how it is, yeah? Option D is a sulfuric acid. You can think about it being like that. In reality, it does not dissociate all in one go. It dissociates to give you the H plus first, and then it dissociates a second time, alright? But I'm just showing you that altogether, it can give you 2 of that H plus. So if you have 1 mole per dm cube of this, because of the 2, therefore you have 2 mole per dm cube of H plus. It's a strong acid, it dissociates fully, and again, because of the stoichiometry, it will actually give you 2 mole dm cube of H plus. You want 1 mole of dm cube of it will have the same concentration of hydrogen ion as the 1 mole per dm cube of hydrochloric acid. Has to be the nitric acid and not the sulfuric acid. Okay, I hope that makes sense then. This next bit of the question is just basically about balancing equation. So if you read the question, you have ammonium. It is ammonium ion. That is a sulfate ion. You have a +1 and a 2 minus. The LCM is 2. The LCM of 1 and 2 is just 2. And your formula is going to be NH4 twice SO4. Alright, so you need 2 of the NH4 to get the correct formula. They are slowly oxidized by air. So you have N2 and oxygen in the air, but the nitrogen-nitrogen triple bonds are going to make it very unreactive. It's actually the oxygen that will do the oxidation. In fact, nitrogen doesn't do the oxidation at all, yeah, because of how unreactive it is due to the strong triple bond. Okay, sulfuric acid, that is H2SO4. Nitric acid is HNO3. Water is H2O. So this is about, do you know your formula? Do you have a good chemistry vocabulary? Okay, so how many moles of oxygen are needed to oxidize completely? 1 mole of ammonium sulfate. So I cannot change the number here. It has to be 1 mole. All right. The thing about balancing this is, you see the sulfate there? 1 of the sulfate is going to give you 1 of the sulfate. So it has to be 1 there. It cannot be any other thing because there's no other sulfur here. Okay. How about the nitrate? The nitrate nitrogen come from the nitrogen here. There's no nitrogen here and here. There's 2 of the ammonium, so there's 2 of the nitrogen. To get 2 of the nitrogen, you must have 2 there. Because I cannot have any other number other than 1, because I want to oxidize completely 1 mole of the ammonium sulfate. Next up is the water. So the only thing that I can think about is there are 2 hydrogen and there are 2 hydrogen, so there are 4 hydrogen there already. Here you have 8 hydrogen, so 8 hydrogen minus 4 hydrogen, there's 2 and 2 there. I need 4 hydrogen atoms there. To get to 4, when I have 2 there, I need 2. Alright, so now just totaling up the oxygen. The sulfate oxygen already balanced the sulfate oxygen, so I don't need to look for that. Look for this instead, and you will see there are 2 times 3 plus 2 times 1. That give me 8 oxygen atoms. That is atoms, and this is an oxygen molecule, so I need 8 of them here. Therefore, I need 4. 4 times 2 is 8, and I don't need necessarily total this up because the sulfate is already balanced by the sulfate. Don't make your life complicated by making the number bigger, alright? Question 14 is about balancing equation again. So let's take, what can we do here? I don't know, I better write down the equation. I can't really see it very well. So maybe if I don't do that, I'm just thinking whether there's an easy way to balance this or not. The carbon I already balanced because 2 carbon there and the 2 carbon there. All the nitrogen, the thing is, there's nitrogen here and there's nitrogen here, and they will give you the nitrogen there. So 2 of the nitrogen give you 1 of the nitrogen. How about the hydrogen? I think the hydrogen is the easier one to balance. 2 times 4 is 8, so there's 8 hydrogen there. And there's no hydrogen there or there, so that must mean I have to have 8 hydrogen. So if I want 8 hydrogen, I need 4 there, so Y must be equal to 4. So A is out, alright? What next? So there's 2 oxygen there. So if I do oxygen, there must be 2 plus. So there's an X there. You see XNO2, right? It says XNO2. So in terms of oxygen, there must be 2 something. 2 plus something will give me 2 times 2, which is 4. And 4 times 1, which is 4. So 2 plus something will give me 8. Something must be 6. And that something refers to the oxygen there. So I need 6 oxygen here. To get 6 oxygen here and to have a 2 there, this must be 3, because 3 times 2 give me 6 oxygen. So this must be 3. So X must be 3. Okay, so B is out. Now Z again, yeah? So Z is the last one. If I look at nitrogen atoms, here I have 2 times 2 nitrogen, so there's 4. Here I have 3 times 1 nitrogen, there's 3. So there's 7. There's no nitrogen there, and there's no nitrogen there. So I need 7 nitrogen atoms. This is a nitrogen molecule. So what can I do? I need 7 nitrogen atoms. 7 over 2 times 2 equal to 7. 7 over 2 is 3.5. Okay, 7 over 2 is 3.5. Hope you can do your improper fractions, yeah, your primary school mathematics, yeah. So this is the last question of this 5-question series. So this is a calculation involving volume of gases. Volume of gases. So they want the final volume of the resultant mixture of gases. Okay, so if I just copy down the equation so that I have more space to work down below here. So this is not your typical hydrocarbon combustion because you also have SO2 there. If I have volume at start, I have 10 cm cube. Okay, so I'm not going to write down the unit, but all of this will be in cm cube. I exploded with 60 cm cube of oxygen. So you could tell from the equation, 1 mole only reacts with 3 mole. So 10 cm cube will only react with 30 cm cube. So this is in excess, all right? So the volume reacted, okay, will be 10 cm cube, will react with 30 cm cube. Because 1 mole of gas reacts with 3 mole of gas. These are gas and gas, all right? Because the mole of a gas is equal to the volume of a gas divided by 24 dm cube per mole, if the volume is in dm cube, okay? Because this is a constant, so the mole of a gas is proportional, is directly proportional to the volume of a gas. Since this is mole ratio and these are volume ratio, 1 mole of this reacts with 3 mole of this, 10 cm cube of this reacts with 30 cm cube of this, okay? So the volume form. So 1 mole of this reacts with 3 mole of this, give you 1 mole of this and 1 mole of this. This is a water at room temperature, cool to room temperature. This is still going to be a gas and liquid, right? Because 1 mole of this forms 1 mole of this. When you have 10 cm cube of this that burns, you will get 10 cm cube of CO2. You will get 10 cm cube of SO2 because 1 mole of this burns to give you 1 mole of it and 1 mole of it. 10 cm cube of this will give you 10 cm cube of this and 10 cm cube of this. Okay, because of the mole ratio. So the volume left at the end. What do you have at the end? You have nothing left. You started with 60, you only reacted 30 because you were in excess, right? And only 1 mole react with 3 moles, 10 cm cube react with 30 cm cube. you have 60 minus 30, you are left with 30 cm cube of unreacted O2. You will have 10 cm cube of CO2 and 10 cm cube of SO2. Final volume, resultant mixture of gases. This is not a gas at room temperature and pressure, it's a liquid. So therefore, what we are looking at really is 30 plus 10 plus 10, which is 50 cm cube. Okay, so we're just looking at that 50 cm cube. So this is the end of this 5-question series on this section, well, topic 1, I guess, moles calculation and stoichiometry. So yeah, subscribe to the channel if you haven't, and spread the words about the channel to your friends and colleagues or teachers, and see if they like this kind of multiple choice question, which can be a good way to practice your theory content, yeah, where you can rewind and you can pause the video and try the question yourself. Okay, thank you for watching.